Okay. So, last class we have finished that speech perception that part. So, let us start with time domain methods in speech processing. So, here we want to discuss about some methods which are in time domain methods. Now, we are not analyzing the frequency of the speech in time domain methods for speech processing, and that is used many cases those kind of methods are used. Okay. So, now first of all that one thing is that once the speech is digitized and taken to the computer. So, these are we are saying that digital signal processing, the speech signal is now in digital domain. So, we always denote the speech signal with x of n. Okay. So, that is a digital signal. We know the sampling frequency of x n, let us is f s. Okay. So, now speech, if you see the speech is a time varying signal, that means along the time, if this is the time axis, then speech property has been changed. This may be voiced, that may be unvoiced, then there may be a voiced, there may be a noise, then there may be a voiced again, then there will be a noise like that. So, speech is not a stationary signal. So, what I say that if I take this portion of the speech, the property is different. If I take this portion of the speech, property is different. Okay. So, speech is changing along the time. Now, what happened? Suppose I want to find out the energy of this whole signal. So, I can easily find out energy E is nothing but a summation of n equal to minus infinity to infinity x square of n. Whole signal, whatever the signal is there, I can take that whole signal at a time x square n, that is the energy. Now, if I take that energy, then if I want to know that okay, this portion is voiced, so energy of this signal is high, this portion is unvoiced, energy is low, this portion is noise, energy is low, compared to this is high, this portion is again voiced, it is high. So, if I want to know that information, if I take the whole signal at a time and find out the energy, so it give me the average energy, or if I make it average, then 1 by I can make the average also. So, if I make the average, so I can get either total energy or average energy of the whole signal. So, that information is whole signal energy is okay, but that does not give me any kind of parameter by which I can process or I can use those parameter to some purpose in the speech processing. So, what we have done, instead of doing that whole signal at a time, we try to analyze the signal for a particular window, okay, for a particular signal, for a particular segment. Now, this segment, I take this segment and find out the parameters and move to the next segment, next segment, next segment, then I can get a segment. So, if this is my f s sampling frequency, so rate of sample in 1 second I get f s number of sample. Okay. Now, if I window the signal, let us 20 millisecond window. So, 1 second signal, how much frame I will get? 50 frame I will get if I slice the whole signal in a 20 millisecond window. So, I get the 50 slice. So, I have a 1 second signal, I slice it every 20 millisecond. So, I get 50 slide. So, then I can say this is f s by 50. So, it is f s by 20. So, instead of f s sampling rate, now for every window I get some parameters. So, parameters are sampled at 20 millisecond per second, means 50 window per second. So, instead of f s number of sample, now I get if each window represent is 1 sample, then I get 50 sample. Now, the problem is that if I do that things, then what will happen, since this boundary, in this boundary effect will come in the processing. So, there may be a this boundary, this boundary may fall in a very large signal. So, that this sample is included this window and this window energy will be less. So, what I want to know, okay, I want to remove this boundary effect also. So, then what we will do? I may take 20 millisecond window, but I slide the window, let us 50% overlap. So, effectively 10 millisecond shift. Okay. So, I can say okay, frame rate in here is in 1 second, then I get 100 frame. Okay. So, if it is frame rate is FR, then I can say that if it is 10 millisecond sliding of the window, I take the window 20 millisecond, but if I slide it 10 millisecond, then I get 100 frame in a second. So, frame rate is 100 frame per second. Here sampling frequency I get Fs number of sample per second. Now, if I say for every 10 millisecond I take a point, then I get 100 point in 1 second signal. So, I can say it is downsample the signal. So, if I want to process the signal, taking every sample is very difficult, because one Fs, if it is 8 kilohertz, 8K sample. So, instead of 8K sample, let us I divide that whole 1 second signal in a 100 frame, and 100 frame for every 10 millisecond I get a parameter. Now, slide the window. So, effectively what I am doing, I am windowing the signal with overlap methods. So, this is window length, let us 20 millisecond, and this is frame shift 10 millisecond. So, 0 to 20 millisecond I take the signal, I process it, find the parameter, I find out the parameter vector, let us vector A, let us it is x 1 or let us A vector 1. Then I shift the window with 10 millisecond and again take the 20 millisecond, I find out A 2 vector. Then I again shift the 10 millisecond and take 20 millisecond A 3. So, in that case I will get A 100. So, if I write like this way, A 1, A 2, A 100 data I will get. Okay. Why I take this one? Why I take 20 millisecond, 10 millisecond? Why I take this kind of statement, or what is the logic behind it? Now, if you see, time speech is an time variant signal. So, if I say that okay, the time along the time speech signal change its color. So, if I want to increase the time resolution, I should analyze the signal for every sample, but that analysis does not provide me any information. So, what I want a small window, let us 5 to 10 millisecond if I shift it. So, for 5 to 10 millisecond window, very short signal. So, due to small amount of data, now if you see the pitch, let us I have taken a 5 millisecond window. Okay. Now, it may be found that within 5 millisecond, maybe 1 or 2 fundamental period is there. If it is male voice, then maybe 1.5 fundamental period is there. So, if I analyze it, it is no use. Now, if I take it let us 100 millisecond, then what will happen? I may lose the transitory portion of a consonant to vowel transition, because speech is changing. So, let us there is a co, burst, then VOT, you know that occlusion, burst, VOT, transition. Now, if I take a 100 millisecond, my window may fall around here. So, what is the information which is very important to know this information? I lost this information, because this information is taken an average with the vowel and some part of the consonant. So, I lose the transitory part. So, instead of 100 millisecond, so if I small amount signal, processing problem, large amount signal, I lose the time resolution. So, what I want a optimum length of the window, so that it does not affect so much. So, I can say let us 20 to 25 millisecond of window if I take, then one transitory period roughly 40 millisecond to 60 millisecond, maybe even faster speech it may be a 30 millisecond. So, at least I can ensure that my window length is lower than the transitory part. Okay. So, then I can say yes, That details signal information along the time I can find out if I take the window length 20-25 millisecond. So, that is why if you say in whole processing of the speech we use 20 to 25 millisecond as a window length and shifted the frame by 10 millisecond. So, that I get 100 frame per second. Okay. You can shifted it 15 millisecond also, but what will happen for every 15 millisecond I get a vector. Okay. In here for every 10 millisecond I get a vector for analysis or for I get a parameter vector. What kind of parameter I can analyze? For every 10 millisecond I get a parameter. If it is fundamental frequency, then also for 10 millisecond I get one pitch parameter. So, it may contain average of 3 or 4 pitch period inside the 10 millisecond, maybe 3 or 4 to 5 pitch period is there if it is female voice. Okay. So, now we are framing the speech signal and shifting the window by 10 milliseconds. So, this is the example if you hear. So, this is the interval 1 and then shifting of the frame by 10 millisecond or less 50%, if it is 20 millisecond window 50% overlap means 10 millisecond shifting. So, I get 100 frame per second. I can take 25 millisecond as a window and shifted the frame 10 millisecond, that also I get 100 frame per second. Okay. Now, this is the processing part I have discussed. Now, what kind of time domain parameters are there? So, I can say short time energy. So, for every window I can find out the short term energy of the speech signal. So, suppose let us application side you can come. Suppose I have a speech signal, there is a voicing, then there is a let us noisy part, then there is a silence part, again there is a voicing part and then again there is a silence part. Now, suppose anyhow I want to find out which part is voicing part and which part is unvoiced or silence part. This I want to find out. So, I want to distinguish between this, I want to mark this point and this point, that I want to mark. Now, if in assumption if you say that if I find out the short term energy of the whole speech signal. So, let us I take this first this window, find out the energy, then 50% overlap, taken window, find out the energy E 1, E 2, then taken energy E 3. So, that way if I find out the energy. Now, if you see, since it is a voicing signal, the energy will be very high. Since it is a noisy signal, the energy value will be very low. If it is a silence, energy will be more low. So, from that short term energy, this E value can give me a plot like this, that this is maybe energy is very high. So, this is high, high, then coming down low, then again it will go high. Because of this kind of transition, because window may take this portion and this portion. So, it is average out the energy. So, that is why you get this kind of transitory part also get. So, from that curve I can find out okay, this up to this point may be the voicing, up to this point may be the silence part. So, that I can easily understand. So, short term energy is one kind of parameter. Then short term average magnitude, short time energy or short time average energy or short time average magnitude. Now, what is the problem in energy? When I calculate energy, the signal x n has to be square up. So, every sample value, let us if it is a 16-bit speech sample. So, let us the value is come around 28,000 for a one sample. So, it is 32,000 plus and 32,000 minus, if it is 8-bit maximum possible. Now, if it is 28,000, if you square it, the number will be integer number will be very high. So, instead of squaring the signal, what I can do? I can find out the short term average energy, short term average magnitude energy. Average magnitude means If it is x n is my signal, so magnitude is mod of x n is the magnitude, and then I can add it, take the average, take the sum value and divide it by the number of sample, I get the average magnitude. So, that I can use as a parameter for this instead of E 1. So, that kind of mathematical details I am coming. So, that I can use it. Then short time zero crossing. If you see a, let us come in here, if you see, I do not know whether there is a time signal is there or not. Okay, I do not have any signal. Now, if you see any signal, any speech signal, if you see that this portion, lot of time signal is crossed the zero line. This portion may be the number of zeros. So, this is the zero line, zero amplitude line. So, zero line crossing will number within a particular window will be less compared to this. So, short time zero crossing can be used to find out whether it is a voice signal or it is a noisy signal. So, short term energy is short term zero crossing can be used. So, the number of zero crossing can be a one parameter. To extract the number of zero crossing can be a time domain parameter. So, this is time domain parameter. I have to extract the for per frame extract the number of zero crossing. Then short time auto correlation I come, then short time average magnitude difference. Those are the parameter I can use from the speech signal, and those every parameter has its own purpose also. Okay. Now, I just come to that one by one. Short time energy mathematics. So, energy E of a signal which is n is equal to minus infinity to infinity x of n square is the energy. So, this is the whole signal energy, long term definition. Now, if I take the long term definition, let us this is my signal, and if I take the whole energy at a time, or this is my signal and I take the whole energy at a time, no use. But I do that with that parameter, because I want to find out voice signal, unvoiced signal, silence. So, if I take the whole signal at a time, find out the energy, I get a value which is energy value of that speech signal, but can I infer any information from that energy value? No. So, there is no use if I use whole signal at a time. So, what I will do, instead of taking whole signal at a time, I will multiply the signal, this signal E for a particular window. So, I cut the signal particular window. Here if I cut the signal, I take the signal of particular window. So, what I am doing it? So, there is a infinite length signal, I place a window over the signal. So, this is L equal to 0 to L minus 1, which is W n. Okay. So, I can say short time energy in vicinity of n cap n. So, T x is equal to x square value and omega n is equal to 1 if it is within L equal to let us n equal to 0 to L minus 1. Okay. Else it is 0. So, I cut the signal from the long signal, I cut a window and take the energy. Okay. So, if I say that find out the short term energy, first I record your let us record your name in a let us Fs is equal to 16 kilohertz and 16 bit mono. Record your name in computer. So, put the microphone connect to the computer, record your name. Once you let your name consist of 3-second signal or let us 5-second signal, long name 5-second signal, it is consist of 5-second speech signal. So, that means 16 kilohertz sample, 16 k sample per second. So, I can get 16 k into 5, 80 k sample. Okay. So, I have a 80k sample this side. I take a window of 20 millisecond. So, I take the sample number 0. So, if it is Fs is 16 kilohertz, then how many sample will be there in 20 millisecond? In 1 second there will be a 16k sample. So, in 1 millisecond 16 sample. So, 120 millisecond I can get 320 sample. Okay. So, there is a 320 sample in 20 millisecond. Okay. I have a take the first frame 0 to 320. And since I am multiplying a window function with amplitude 1, so that means from take every sample. So, let us take this is x n. So, I take x 0, then I take sum x equal let us k equal to 0 to 320 minus 1. So, n L is equal to 320, L minus 1 x of k, x square of k equal to E 1. So, first frame power I get. Then I shifted this frame by 10 millisecond. That means 10 millisecond means 320 divided by 2. So, that means 160 sample. So, I take that another window from 160 sample to here. Okay. So, this is 0 to 319 sample. So, this is 160 sample to another. So, here will be 319 plus 160. So, I take that sample and find out E 2. Then that way I can. So, if it is 10 millisecond shifting. So, I get 100 frame per second. So, in 5 second I will get 500 frame. So, I can get E 1, E 2, E 3 dot E 500. So, I get 500 short term energy data point. Now, if I told you that if I draw that this diagram. So, what is the diagram? Here is x n, this is f s. If it is energy, then this function is square. So, if it is short term energy, then I can find out. Okay, let us this is my signal x n, whose sampling frequency is f s. Operator is x of. So, I can say square. Square is the operator, signal square, I take the signal square, then I pass the signal. So, all signal is every sample is square, rate is still f s. Now, once I pass through the window W n, after the window my rate is f s by r. F s by r. R is the shifting 10 if it is 10 millisecond. So, if it is for every 10 millisecond I get one sample, you can say that one data. So, I can say here I get E n, which is nothing but a for every 10 if it is 10 millisecond shifting. So, 100 frame 100 per second, earlier it is f s, let us it is 1 f s per f s number of sample per second. Instead of f s number of sample, I get 100 number of sample per second. So, I get E n value, E n is equal to 1 2 dot 100 for 1 second. Here f s sampling sample 1 2 up to f s number of sample. Okay or not? Okay. So, this is called, I can say that short term energy. Now, if I interested instead of energy, I can replace this box, same box by only magnitude. Again it is f s, again if I put a window W n, I get f s by r, that is m n. So, instead of squaring the signal, so m n is nothing but a, let us k equal to 0 to L minus 1, that is within the vicinity of the window length. You are taking x of m, let us x of k mod into W n minus k, where n is the here m n. N is the starting window, number of windows. So, if it is first window, n value equal to 0. If it is second window, n value is equal to 160. Shifting is 160 sample. If it is third window, n value will be, starting of the window will be 320. Fourth window, starting of the window will be 320 plus 60. So, I can get. So, for every window I get 1 mn. Okay. So, then I get mn. So, instead of I can get En, I can get mn. En is the short term energy, mn is the average magnitude. Okay. Average magnitude. It is, sorry, it is a sum of magnitude. If I want to make it average, 1 by, put 1 by L here. So, I can normalize it also 1 by L. L number of sample are there. So, I can 1 by L, I get the average. Okay. So, average magnitude. So, using these two, so this is some plot of those two parameters. You can extract after recording your name, extract that En. So, I give you the problem. So, problem is you record your name in 16 bit 16 kilohertz and 16 bit 16 kilohertz and mono. Record your name using any, you can use CoolEdit, you can use Pratt, record it. Then find out En and Mn, value of En and Mn. En in the rate of 100 frame per second and 20 millisecond is the window length. Take 20 millisecond window length and find out the 100 frame shift is 10 millisecond. Find out the En and Mn. Then plot the three signal. One is your first recorded signal, then plot it En, then plot Mn. So, for recorded signal, there are lot of samples will be there. For En, for 1 second I get 10 sample value. For Mn also, for 1 second I get 10 sample value. Now, you see whether you able to find out the voice zone using En and Mn or not. So, maybe if it is voice zone, En value will be high, if it is unvoiced or sibilant, maybe if it is noisy unvoiced, amplitude may not be that much of fall, amplitude may rise somewhere and then again voicing zone it may rise. Sometime if it is voice bar like this. So, I do not know whether it is a voice bar and whether it is a noise. So, for that purpose we use another parameter, but at least using En I can find out where the speech signal has high energy, where it is there is no energy, that I can find out. So, this can be used as a voice detection. You plot it and see it how it is behave like. Okay? Then you can get a real exposure. Now, another parameter is called zero crossing. If you see zero crossing, yes, is an zero crossing. If it is a sine wave, let us sine wave. So, how many time signal crosses the zero line? So, it is 1, 2, if it is period. So, if it is I start from 1, then 1, 2, then this point is part of the next period. So, I can say if it is a pure sine wave, then 2 number of zero crossing per cycle. Per cycles, 2 number of zero crossing. Okay. Now, what will happen if you say sometime you may say that I have recorded the signal and this is my zero line, zero amplitude line by my sine wave in here, it never crosses the zero line. That means, there is a zero line, but the sine wave is DC shifted. DC shifted means the 0, there is a sine wave during the recording, there is a DC shift in above. That is why 0 line shifted to here, 0 line is DC line. So, if it is DC shifted, what I can do, either I can pass the signal through a low pass filter, or I can take the average and subtract it. So, first normalize the DC shift of the signal, then find out the 0 crossing. Okay. Now, just come to the calculation, then derive that equation, then find out the parameters. Now, if we see that if it is a pure sine wave, 2 number of 0 crossing per cycle. Now, if the sampling frequency of this sine wave is Fs and the fundamental frequency is F0, that means length of the period is 1 by F0, then I can say Fs by F0 number of Fs by F0 sample per cycle. So, how many sample will be there in per cycle? Fs by F0. So, if it is a 8 kilohertz sampling frequency and I have a 200 hertz F0, then how many samples will be there in one cycle? 8K divided by 200 hertz. So, 40 sample per cycle. Okay. So, this is number of sample, or I can say sample per cycle. Now, if you see 2 number of 0 crossing per cycle. So, number of 0 crossing Z1 is equal to 2 crossing per cycle into cycle per sample. This is sample per cycle. So, cycle per sample is nothing but a F0 by Fs. So, I can say twice F0 by Fs number of 0 crossing per sample. Number of 0 crossing per sample. So, if I want to find out the number of 0 crossing of 80 sample. So, let us m sample, then Z1 is nothing but a 2 F0 by Fs into m. Okay. So, next class we try to derive the generalized formula. How do I find out the 0 crossing for non-periodic signal, or you can say the for speech signal, or the periodicity is periodicity quasi-periodic signal. So, for there how do I find out, or even non-periodic signal, how do I find out the number of 0 crossing. Okay.